afternoon, this is Joey and this is my third video. We're going to talk about variables, variable expression, evaluating valuable expressions, and ultimately we're going to talk about equations. Now when we talk about variables are symbols that represent a number, or maybe some numbers. For example, if you recall, one variable is example is pi, so that one represents 3.1416, and this is one of the favorites because this one is used to compute the circumference, okay, not the circumference of the circle. So 3.1416 is actually the ratio of the circumference over the diameter of the circle. Anyway, that's one example. Now variables can also be letters. Okay, they can represent a number. So if you use a variable, for example, you choose a, it has to represent a number unique to all the other variables in the equation. So let's put some arbitrary figures. Let's take, for example, this equation. Our main equation is a plus b minus c equals x minus f. Okay, so let's put some arbitrary figures. Let's say a is number 8, b equals number 2, c equals 5, x equals 6, and f equals 1 respectively. So if you put them all together, used in the main equation, this is what it should look like. So that is 8 plus 2 minus 5 equals 6 minus 1. Again, it does make sense because if you combine the like terms, 10 minus 5, if you evaluate these terms, 6 minus 1 equals 5, and so 10 minus 5, 5 equals 5. Okay. So we're going to use that equation using these arbitrary figures for our variables. Sorry. Okay, let's proceed. Let's try to solve for a. What's the equation going to look like if we are going to solve for a? Now when we're going to solve for a, we're going to isolate that variable at one side of the equation. So in this equation, the equal sign is the one that says, that's the one in the middle. So variables at the left side of the equation is positive a, positive b, negative c, and variables at the right side of the equation is negative f and positive x. So we want to solve for a. Remember I mentioned that we are going to isolate a in one side of the equation. So we're going to say a equals x minus f. So those are the guys over here. Now we're going to move b to the right side of the equation. So when you transpose it, it becomes negative b. And because this one is a negative c, when you transpose it to the right side of the equation, it now becomes positive c. And so this is the equation that will solve for a. Let's try to see if it works. So a equals 8, x equals 6 minus 1, value of b becomes negative 2 and positive 5. Let's try to solve it. 6 plus 5 is 11, so we're going to combine positive numbers, and then we're also going to combine the negative numbers. Minus 8 minus 3. So 11 minus 3 is, of course, 8. So we have now the equation for solving A. Okay. So let's move on. Let's now solve for B. I like that. Solve for B. This time we're going to isolate B. B equals, copy those variables at the right side. They just stay over there. And then A moves to the right side, so it's positive. It now becomes negative A. And this one is negative C. It becomes positive C. Let's see if it works. B equals number 2. X equals 6 minus 1 minus 8 plus 5. Let's see if this is going to be true. So we're going to combine the negatives. So this is negative 9 plus 11. Okay. So this is 2. Or 11 minus 9, that is 2. So we have successfully solved for B. Okay. Now, let's solve for C. We're going to employ a new technique because this one's a negative number. And this becomes isolated. So negative C equals, I forgot to change this. So we're going to solve for C. This negative C equals X minus F. And all those that move there, that's going to be negative A and negative B. But we cannot have a negative number or a negative variable as the representation for the final equation. We want to make sure that C is positive. Now remember, I told you a variable has invisible numbers around it. Okay, when you look at C as a variable, let's change the pen. Let's hope that it writes differently. Okay, C. And when you look at C as a variable, remember that it's got denominator 1. Its numerical value is 1. And it's got an exponent which is also 1. Having said that, with a negative C, this one has a negative 1 beside it. So negative 1 multiplied to C. That's now going to be X minus F minus A plus B. I'm sorry, minus B. Now here's what you are going to do to make your C a positive number. Now recall that the negative 1 is beside it. Let's bring it down. We're going to divide it by negative 1, and so is it. It's also going to happen to the other side of the equation. Negative 1. So negative 1 divided by negative 1 becomes positive. So now this is C. It's now positive. And this is positive divided by 1. Negative 1. So it now becomes negative X. Positive F. Positive A. Positive B. Let's try our arbitrary figures now. Let's see if it works. C is 5, right? So negative 6 plus 1 plus 8 plus 2. And if you combine these terms, this is what's going to happen. Negative 6 plus 11. And that is 5. Okay. So we have solved for the value of C. Let's move on. Let's try to solve for X. We're going to delete this. Okay. This time we're going to solve for X. Now I just want to let you know that this format can also be written in a different format. It's an equivalent equation, so it can also be written as X minus F equals A plus B minus C. So that's an equivalent equation. And now we're going to solve for X. So isolate X. A plus B minus C. You transpose F, it becomes positive. And so now this is the equation for X. Let's see if it works. X equals 6. A equals 8 plus 2 minus 5 plus 1. Let's see if it works. 8 plus 2 is 10 plus 1 is 11. And 11 minus 5, that's 6. So once again, we have solved for the missing or the unknown. We have solved for X. Let's move on to the last variable. We would like to solve for negative F. We're actually going to solve for F, not negative F. We're going to solve for F. Again, let's write the equivalent equation of A plus B minus C equals X minus F. The equivalent equation is X minus F equals A plus B minus C. So let's isolate F. A plus B minus C, and there's your X, which moved to the right side, it becomes negative X. So now F is negative, and we know that the numerical coefficient of F is a negative 1. Okay, so we got A plus B minus C minus X. So let's divide them by negative 1. Also at the other end, F now becomes negative A, negative B, positive C, positive X. And let's use our arbitrary figures. Let's look at that side over there. Yes. F equals 1. Let's see what happens. This is negative 8, negative 2, plus 5, plus 6. And if we solve it, 8 minus 2 is negative 10, plus 11, so 1 equals 1. There we go. Let me know if you were able to follow. If not, we're going to talk about it again so that we can see what we can do to help you focus more on equations, variables, and evaluating variables. Thanks for listening.